Welcome to All Wired Up, where you dive into exciting topics around tech, innovation, AI, and the future of digital life. Strap in, subscribe, and enjoy the journey.
Welcome to All Wired Up. Today we're diving into LLM tokenization. Have you ever marveled at how an AI, a large language model, can write a poem, translate languages, or even debug code with seemingly human-like intelligence? It is truly incredible. But then, have you also scratched your head when that very same AI struggles with something as simple as spelling strawberry correctly, or maybe gets tripped up on basic arithmetic, like telling you that 1 + 1 = 11 instead of 2? It seems a bit like a super genius who can't tie their shoelaces, doesn't it? This puzzling behavior points to a fundamental difference in how AI processes information compared to how we humans do. We see words, sentences, and numbers as coherent units, full of meaning. But in AI, it doesn't. It sees the world of text in discrete chunks, in pieces, in something called tokens. Today, we are going to pull back the curtain on this essential, yet often overlooked, process known as tokenization. We'll explore what tokens are, how they work, and why understanding them is key to truly grasping the strengths and limitations of our most advanced AI models. So let's start with the basics. What exactly is tokenization? Imagine you have a long piece of text, say, this very script. For a computer, this is just a very long, continuous string of characters. Our large language models, or LLMs, can't process text in this raw, flowing format. They need to break it down. Think of it like a chef preparing a meal. They don't just throw all the ingredients into a pot. They first chop vegetables, dice meat, and measure spices. Tokenization is that initial chopping and dicing process for text. In more technical terms, tokenization is the process of taking a sequence of text and breaking it up into a bunch of discrete components. These are our AGI tokens. These tokens can be a whole word, part of a word, a single character, or even punctuation. Once these tokens are created, each one is assigned a unique integer. So the word the might become 123, while cat might be 456. These integers are the actual language that the LLM understands and works with. The magic behind this process lies in something called a tokenizer. This isn't a generic tool. Each LLM, like those powering ChatGPT, uses a specialized tokenizer, often trained on massive datasets of text itself. These tokenizers learn patterns in language, figuring out the most common sequences of characters that form meaningful chunks. For instance, the tick token library is what OpenAI uses for its models. So when you type a prompt, it first goes through this tokenizer, which breaks it down into a sequence of numbers, which the model can then understand and process. Now you might be wondering, why not just use whole words as tokens? This is where the brilliance of subword tokenization comes in. Imagine the word unbelievable. If an LLM only recognized whole words, it would need to know every single word in existence, including all its variations. That's a huge vocabulary to learn. Instead, tokenizers can break down unbelievable into believe, everyable. This subword approach dramatically reduces the dimensionality of the language space, meaning the model has fewer unique pieces to learn and track. This is crucial for making these models possible in principle. It also helps with words the model has never seen before. If it sees supercalifragilisticexpialidocious for the first time, it might break it into familiar subword units, rather than treating it as a completely unknown, unprocessable entity. This ability to generalize is one of the superpowers of tokenization. Tokenization is not just a pre-processing step. It is the very first step in training an LLM. It defines how the model sees and interprets the entire world of human language. The LLM then analyzes the semantic relationships between these tokens, how often they appear together, in what context, and what they signify. This is how the model builds its understanding of grammar, meaning, and context. Without precise tokenization, the entire edifice of an LLM would crumble. In fact, The choice of tokenizer can significantly impact an LLM's downstream performance and even its training costs. A poorly chosen tokenizer might create inefficient tokens, leading to more tokens per given text, which means more computation. Conversely, a well-designed tokenizer can be a secret weapon, making the model more accurate and efficient. It is truly a necessary and sometimes neglected evil of large language models, as one researcher put it. And this brings us back to our initial mystery. Why does AI struggle with spelling strawberry or simple math? When you type strawberry, the AI's tokenizer might break it down into strawberry. This is fine if the model has learned that these two subwords together form strawberry, but if it encounters str_a_berry or strawby_rry due to a tokenization boundary or an unfamiliar spelling, it gets confused. It doesn't see strawberry as a whole word to be spelled correctly, but as a sequence of discrete numerical tokens. The same applies to numbers. If an AI sees 1 plus 1, it might tokenize it as 1 plus 1. If its training didn't sufficiently emphasize the arithmetic operation of the plus token in that context, it might treat the E1s as adjacent tokens to be combined, leading to E11 instead of 2. It doesn't understand numbers as quantities in the same way we do, but as sequences of numeral tokens. This is a crucial distinction that explains many of their quirky errors. So the next time you interact with an LLM, remember the invisible work of tokenization happening behind the scenes. It is not just a technical detail. It is the fundamental way these incredible machines perceive and process our language. This understanding helps us appreciate their intelligence, while also recognizing the inherent limitations of their token-based worldview. It is a brilliant design choice that enables powerful AI, but also one that requires us to adapt our expectations to how AI truly thinks. Thank you for joining us on this journey to demystify tokens. Thanks for watching. Don't forget to subscribe and share. See you later. Be awesome.
I hope that was insightful. Thank you for watching. Don't forget to like, subscribe, and share. Be awesome.